Alright folks, we're continuing on with the ZF Gearbox controller project here, and what I'm hoping to be able to run through today, just on the electronic side of the control system, will be some of the inputs and outputs that we need to cater for in the control system. Now, typically what we're going to be looking at, there's going to be two main areas that we need to bring in and out of our controller. Now, I've got some cable harnesses here that I'm going to just put on the bench, and we'll run through some of the connections and some of what we're going to be doing with them. So, first harness here, let me get rid of that one for a second. This harness here is the smaller of the two, and as we'll see later outside on the gearbox, this connects in or about the bell housing area, and on this plug here we have 5 pins, and on this one we have 2 pins. Now this plug here is designed to connect to the RPM pickup that's just inside the bell housing, and if we recall looking at the flex plate flywheel, there's got all the little teeth on it, so the sensor picks that up and gives us an RPM signal, so we'll be able to use that probably for a controller or something like that, but at the minute that won't be doing anything. Now, more interestingly is the 5-pin plug. 5-pin plug, and we have a wiring bundle here comprising 5 wires. Now, what these are the connections for what's called the transmission range switch, and what that is this little guy. Now, I hope this is going to come out on camera, so have a look at it. I think it might be okay. So the transmission range switch is a switch that's on the side of the gearbox and is connected to the input from the shifter. And basically what we have is we have a kind of a truth table here, that we have P, R, N, D, 4, 3 and 2 are the possible positions for the shifter. We have 4 switches inside the range switch. We have 1 common input wire. We have 4 corresponding outputs that go to the transmission controller. Now, depending upon where we have the shifter, various combinations of these 4 switches are either closed or open. So for example, if we're in park, L1 and L2 and L4 are closed, but L3 is open, and so on as we go down through the various ranges. So our 5-wire connector basically gives us access to these 4 switches, and let's see where it's gone on me, the actual color code for anyone that's interested is that the green is the common, so that's basically this guy here. That's the common, and then we have black, violet, orange and grey for the 4 switches. Now the platform that I'm going to be using for the controller is an Arduino Uno microcontroller system, and that has quite an array of inputs and outputs. Now I'm going to have to jump around a little bit here, because what we need to look at then are what we need to actually, what signals do we need to send out to the gearbox to shift it. Now, what we need to do now is to have a look at our connector. And this is the second of the two electrical connectors to the gearbox, and it's the bigger one, this guy. It's a 16-pin connector with a lot of cables in it, and this basically equates to the various solenoid valves and sensors that are inside the gearbox. So for example, we have MV1, 2 and 3, which are on-off valves, and we have EDS 1 through 5, which are proportional valves. We have a temperature sensor, which gives us the temperature of the fluid in the gearbox. We have a TSS, which is the turbine speed sensor, which is essentially the input speed to the gearbox. And we have OSS, which is the output speed sensor. So obviously we need to drive these valves, but the next question is, well, how are we going to do that, and how are we going to know how to drive the valves? So this is a very handy manual, and it gives us a lot of information on this. Now, one of the most important factors, sorry I skipped over something I should have mentioned here. If we have a look at, and we have a read through this manual, one of the things that we will read on it are to do with the resistances of the various solenoids. Now EDS1, which is this guy here, which is between pins 2 and 12, has a resistance of between 5.2 and 6.8 ohms. Now this valve here, EDS1, is responsible for the main line pressure control in the gearbox. So what we need to do to control that valve is, and indeed all of the other EDS proportional valves, is to provide them with a 5-volt PWM signal. Now you might say to me, how do I know that it's a 5-volt signal? Because that's not actually specified anywhere. Well, if we have a look at the resistance, and we look at probably a mid-range value for that is about 6 ohms. And according to the manual, the valve is fully turned on when there is 0.8 amps flowing through it. So if we do a little bit of maths around Ohm's law on that, that essentially gives us a 5-volt signal. Now our little Arduino board has got quite a few PWM outputs on it. I think it's actually got 5 of them, so it's pretty much perfect for this application. But the problem is they're only capable of sinking or sourcing about 20 milliamps of current, so that's not going to hack it for driving the valve body. So what we need to do is to boost that up a little bit. Now, I was having a look around and I came upon this little guy. This is it says a lead Arduino on it. It's literally a board that I bought on eBay. It is designed, I believe, for driving high-powered RGB LEDs. And what it does is it gives us 5 PWM channels from the Arduino, but with about 8 amps per channel driving power on them, and it gives us 4 I/O lines with about 8 amps per channel. Now obviously the maximum current for the card is a lot less than that. It's about, I think it's limited to about 10 amps, but if we have a look at our chart again here, we see that we have 3 MVs, which are manual valves, which are basically on or off, which our general purpose I/O channels will be able to handle. And we have 5 valves that require PWM, and we have 5 PWM channels here all set. So this little lead Arduino board will basically just clip in on top of our Arduino, and that gives us quite a nice assembly to get started with, and it gives us screw terminal blocks, the whole lot. So now there is one other thing that we need to be conscious of. We need freewheeling diodes for the valves, particularly the ones that we'd be doing the PWM on. So we need some of these guys, which are some nice ultra-fast soft recovery diodes. This is a STT-H512D part, which is something crazy, like it's a 1200 volt 50 amp diode or something like that. So they will just basically go in here into the screw terminal along with the connections for the solenoid, and will give me freewheeling capability on my solenoids, which is kind of handy. So otherwise things go tst and bang and all that, so that's not good. So this here takes care of my output controls to the solenoid valves. Now we've still got to bring in the transmission range switch, the transmission temperature sensor, the turbine speed sensor, and the output speed sensor. So we're starting to get tight on our I/O lines, and if I were to go to use the 4 digital channels for the range switch, that would not work out for me because I'd have too few channels. So what I decided to do was to have a look at the possibility of just using one line, one analog to digital input, to be precise. And I came up with this idea. Now I hope this is going to come out, because as we all know, my filming skills aren't exactly great. So what I decided to do was to have a look at adding all 4 of the switches together with a resistor ladder and make a potential divider in such a way that wherever the gear selector may be, that we can actually produce an analog voltage that we can read in through one analog input pin on the Arduino to determine the position of the gear shifter. Came up with a system here basically, which is as we can hopefully see. Basically we have 5 resistors in total, one on each of the 4 outputs and then one common. And basically through whichever combination of switches are closed, we apply a 5-volt signal to the common. That was that green wire we saw there. So if we look at this, we'll be applying 5 volts to that green, and then we'll be putting a resistor of different value on each of the 4 outputs from the range switch, and going ahead then and setting up a potential divider that'll give a variable voltage output based upon where the selector is positioned. So we've then got just the basic calculations done out here based upon some fairly arbitrary resistor values. Will give us voltages, and so we can just feed those into the analog pin, and I need to write some software to determine the exact position of the shifter. Then once we know where the shifter is at any point in time, the next phase of the operation is for our software to then decide what to do with the various valves that we're going to be controlling with the FETs and the LED Arduino scenario. So back to our manual once again, and we're going to see what we need to do with our here we go. See what we need to do with our valves. Now this is the ZF5HP24 solenoid application chart. I'll try and get a bit of a better view on that if I can. Oops. There we go. Now what we can hopefully see here is that we have all of the possible positions, all the possible ranges that the gearbox can be set in. Park, reverse, neutral, D1, 2, 3, 4, 5 and 5th with the TCC engaged. Now we then have correspondingly across the top we have the 3 manual valves and the relevant states, be they on or off, for all of those positions. And we then have the 5 EDS valves, which are the proportional valves as we originally mentioned. Now EDS 1 is the line pressure control valve. Now when that valve is fully turned on and it's got a 5-volt supply to it, line pressure is at well, it's probably not 0, but it's at minimum. And when the valve is fully turned off, we have full line pressure. EDS 4 is used to control the torque converter clutch. So we can vary the application of the torque converter clutch by means of how we control EDS 4. We then have EDS 2, 3 and 5 that are used in conjunction with the manual valves to determine, basically from what I can decipher from all of this stuff, is basically the how harsh that we actually shift the gears. So there'll be some experimentation based around them, when both on the bench and when the car is actually driving. But we have more than enough info here to actually write some software and get a bit of hardware designed and operating, even without spinning the gearbox at all at this stage. So to get us something functional that we can actually try out. So what I'm going to do is I'm going to go ahead and get some of this hardware put together, and I'm going to get a little bit of software written. We'll come back then, hopefully, when we have some of that done, and we can actually run the gearbox selector through the various positions and make sure that it's determining the correct state based on this info here, and then we can see how it's controlling the valves and so forth. So stay with us, folks. Okay, so we're back out with the gearbox, and centre of the shot here we will see what is the range selector switch, and basically this is what we described earlier, and it has an electrical connection here that runs along the front of the sump pan and essentially goes around to an electrical plug that I'm hoping to be able to show you, that just is in on that side of the gearbox, pretty much there. So we've got that guy plugged in, got our little resistor divider network that we described just in some sleeving here, and we go down to 2 wires then that are going into our Arduino. Again, as previously outlined, we're just going in on the Arduino onto its analog 0 pin with the blue wire, and the orange wire is bringing out 5 volts from the Arduino's internal regulator. And there goes the power lab. Give me 1 second, I'll be right back. And sorry about that, folks, just in the middle of a bottom balancing job as well as trying to sort out the gearbox controller. So what I've done is I've written some very simple software for the Arduino that basically just reads out the value from analog 0 every 1 second and transmits that to the serial monitor that I've running on the laptop here. So I'm going to go ahead and start up the serial monitor, and I'll put a voice scripts just on the shifter just so I can shift the gearbox, and we'll see what values that we actually get coming out of this thing. And I'm going to make a little section just here in the software so I can note the values, and then I'll be able to write some code around deciding what those values mean. I'll probably have to put a little bit of a fudge factor around some of them. 4, 3 and 2. So if we start up the serial monitor at that, there we go. So we're in park right now, and I'm getting 584 as my reading. I'll try and see if we can just close in on that a little bit there. Oops, there we go. Bloody comedy club filming here for sure. Probably don't even going to see a bloody white screen, I'd say, at this stage. Let me see what I can do here. There we go, that might start to look a little bit better. I don't know how that's going to come out. But anyway, we're getting 583, 584 on our analog channel there, just in. Just going to put that over here. And there goes that bloody Power Lab again. That thing is really starting to give me a bad hair day, I have to say. So, Park is about 584. 584. So let's go to reverse. That's reverse. And we're now getting 515 or so. About 514, 515. 515 for reverse. Neutral. There's neutral. Neutral looks to be giving me around 643. So 643 for neutral. Drive. There's drive. Drive is at 323, 324. So it looks like 324, 323. I'll call it 324. Fourth. Ooh, big drop. Down to around 91 for fourth. 91. Third gear. And we're back up to around 368 for third gear. 368, 369. And finally second gear. About 627, about 626, 627. So let's call it 626. So we can save that. That's that saved, and we now know that whatever value that we see coming out of the range switch, we can translate into actual values. Okay, so we just might be actually able to see the values now. So that's us there. That's us there in Park, basically. And we're going to just run back through the values again. So we're reading about 583, 584 at the minute. So I'll just do reverse. Oh, that's not reverse. There we go. There's reverse. So about 515 for reverse. Neutral to 644, 643. Screen brightness keeps varying because I'm on battery here. I'm trying to turn that off. That's neutral, drive. Drive about 324, 323. Fourth gear, 9091. Third, $368 or so, and finally second. 626, 627. So all the way back to Park, and we're done. And that's our transmission range switch pretty much set up. So all I've got to do now is to basically translate those numerical values that we read from the analog input on the Arduino into an actual value that we can basically discern where the shifter is. So stand by for more. Okay folks, so I've written a little bit of software just to give a more kind of a human meaning to the position of the shifter. So I'm just going to run through them. We're in park at the minute, obviously, so let's see what happens. So park, reverse, neutral, drive, fourth, third, and finally second. So there we go, looking good. And all the way back to park. And that's us. So we now have a means of decoding the range selector switch just by means of two wires into our little Arduino. So next time we'll be looking at actually controlling the solenoid valves with the Arduino, and pretty soon now we'll be getting the gearbox spinning. Got the adapter plate materials coming in, so we'll be looking at that and some more of the physical mechanical side of the plan. So stay with us, and we'll be back soon.